The diagram above shows a plan of a patio. The patio PQRS is in the shape of a sector of a circle with a center Q and radius 6 meters. Given that the length of the straight line PR is 6 root 3 meters, find the exact size of angle PQR in radians. If they ask for exact size, they're asking for answer with no decimal places. So the answer is either going to be in pi or in root. The angle we're looking for is angle PQR. We need 3 points to find an angle, so that's the angle we're looking for. And to find that angle, we have to use, we've got 3 sides. We've got side here, we've got that side, but we haven't got the angle. So the best way to find that is to use cosine rule. So the cosine rule in this case will be cos of Q, because that's the angle in the middle there, equals PQ squared plus QR squared. Those are the two adjacent to the angle, minus the opposite angle, which is PR squared over 2 times the two adjacent side, PQ times QR. And that will be 6 squared plus 6 squared minus 6 root 3 all squared over 2 times 6 times 6, and that equals 36 plus 36 minus 108. That would be 36 times 3, because 6 squared would be 36. Root of 3 squared would be 3. 36 times 3 is 108. And that would be 2 times 36, that's 72. And so that would be 72 minus 108 over 72, and that's still cos Q. So cos of Q equals minus 36 over 72, which gives minus a half. In order to find Q, we need to divide both sides by cos. Q equals 1 over cos, open bracket, minus a half, and that will be 1 over cos in indices is cos to power minus 1, which is inverse cos. So that will be cos to power minus 1, open bracket, minus a half. So Q, to now find Q, we need to find the inverse cos in radians. If you look on top of your calculator screen, you should see R. R indicates it's in the radians mode. If it's not, you need to go press Shift, then Menu, then you need to press 2 for angle unit, and then press 2 for radians. And if you look back on the top of your screen, you will see R. That means it's ready for radians. And in that case, to do inverse cos, you press Shift cos, that will give you inverse cos. Press the fraction key, which is below the option button, and put minus 1, arrow down, 2, arrow to the right, and then close it, and equals, so that should give you 2 pi over 3. Well, pi over 3 is 60 degrees because pi is, we know that pi equals 180 degrees, and that 2 pi equals 360 degrees. So 2 pi over 3 will be 120 degrees. So the angle we're looking for, PQR, equals 2 pi over 3. And that's the answer for that one. B, show that the area of the patio PQRS is 12 pi meters squared. The angle of the patio here is 2 pi over 3. And to find the area, we need to use, because this is a sector, so we need to use so area of sector will be equal to a half r squared times theta in radians. And we know r equals 6. So a half times 6 squared times 2 pi over 3. That equals 36 over 2 times 2 pi over 3. 2 cancel 2. 3 goes there 1. 3 goes there 12. So the answer is 12 pi. So that's the area of the sector. And that's what we're looking for. 12 pi meters squared. C, find the exact area of the triangle PQR. So we want to find the area of the triangle PQR. We know the angle here, again, it's 2 pi over 3. So the area of the triangle will be, equals a half PQ times, that's times, QR sine Q. And this angle in the center is Q. And so that would be 6 over 2 times 6 times sine 2 pi over 3. And that will be 36 over 2 sine 2 pi over 3. And that will be 18 sine 2 pi over 3. Again, you have to do this in radians. So make sure your calculator is in radians. So if you type in 18 sine 2 pi over 3 is times root 3 over 2. Again, you have to do it in radians. You get root 3 over 2. Or you can work it out from the unit circle. So if you do a unit circle, you could work it out that way. Here's a unit circle. And sine of 60 degrees, if I go there, that's 60 degrees is, sine is the height here. So that's y, that's x. Sine is the y value. And the y value is, for 60 degrees, that would be root 3 over 2. And if you extend that to the other side here, that's 120. So if you draw that, so this one here, and if you, so from there to there is 60, and from there to there is 120. So this angle here is 120 degrees, and the sine for that is this height here. It's same as the 62, so that is still root 3 over 2. So that's how to find it with a unit circle, where the radius r equals 1. And the y value is the sine, and the x value is the cos. So that's cos of x, and this is sine of x. So because 120 is same height as 60, so therefore the value is root 3 over 2. Also for 120, for 2 pi over 3, because this angle here is pi over 3, so this angle here would be 2 pi over 3. And that's what we've got. And that would become 9 root 3. That will become 9 root 3 because 2 cancel here, 1, and 2 goes there, 9. So the area of the triangle, is 9 root 3 meters squared. And that's the answer we're looking for. D. Find in meters squared to one decimal place the area of the segment PRS. PRS is a segment, so if I shade that area, this is a segment, that's what we want. We want to find that area. We found earlier that the area of the sector equals 12 pi, and the area of the triangle equals 9 root 3. To find the area of the segment, we take away the triangle from the sector. So area of segment equals area of sector minus area of triangle, and that would be 12 pi. So that would be 12 pi minus 9 root 3. 12 pi, if you plug that into calculator, is 37.699 minus 15.588, and the final answer for that, if you take away, is 22.1 meters squared. So now the area of the segment is 22.1 meters squared. Find E. Find in meter to one decimal place the perimeter of the patio PQRS. To find the perimeter, we need to find the arc PRS of the sector. And the formula for the arc of a sector is L is the arc times radius times the angle theta. And in this case, the radius is 6 times 2 pi over 3. Now 2 pi over 3, that's 2 times shift times 10 to the power x will give you pi, divided by 3, you get 2.094. So that will be 6 times 2.09439.5. If you times it by 6, you get, so that's 12.566. And to find the perimeter, you just add up all the sides in this case. So the perimeter is 12.566 plus 12, that would be 24.566. We need to find the answer in one decimal place, so that would be 24.6 meters. So that will be the perimeter. And that's the answer we're looking for.